Lesson 10.7, Using Trigonometric Identities. On the unit circle, x is cosine theta. That was because cosine was x over r. If r is 1, because it's a 1 unit, cosine is just x. Likewise, y is just sine, because sine was y over r. But if r is 1, it's just y. The equation of a unit circle is x squared plus y squared equals 1. So if I substitute that in, I get cosine squared plus sine squared equals 1. That's called an identity, which is a statement showing a relationship between two quantities that are always equal, no matter what value I plug in for the angle. When I do cosine squared of that angle plus sine squared of that angle, it'll always equal 1. Here are some other identities. Sine of u is 1 over cosecant u. So that just is saying sine and cosecant are reciprocals. Cosine and secant are reciprocals. And tangent and cotangent are reciprocals. The ones that are red, I suggest you memorize. Quotient identities. Tangent is sine divided by cosine. And since cotangent is the reciprocal, cotangent should be cosine over sine. And then we have Pythagorean identities. Sine squared plus cosine squared equals 1. If I divide both sides by cosine squared, it would become that. Or if I went back to the sine squared plus cosine squared equals 1 and divided both sides by sine squared, you get that one. Again, the red ones you should memorize. And even more identities, even odd. Cosine of negative u equals cosine of u. Same thing for secant. So that's even. That's the definition of an even function. So the function of a negative input equals the same thing as the function of the positive input. The rest of these are odd. Sine of negative u equals negative sine u. Tangent of negative u equals negative tangent of u. And so on. So those are odd. And then the cofunction identities. Sine of pi over 2 minus u equals cosine. So this comes from the right triangle. So if this is u, that angle is pi over 2 minus u. So it's saying sine of this angle equals cosine of that angle. And that's true because here's opposite from u, that's adjacent from the other angle, so it would be cosine. So anything, the sine and cosine, tangent and cotangent, secant and cosecant, they're paired like that. So we can use identities to evaluate parts of triangles. Given that sine is negative 5 over 13, and our angle is between pi and 3 pi over 2, find the values of the other 5 trig functions of theta. Alright, so for between pi, which is here, and 3 pi over 2, means we're down here somewhere, and we are in quadrant 3, which means x is negative and y is negative. All right, since we know sine, we could find cosine. So sine squared theta plus cosine squared theta equals 1. Well, sine is negative 5 over 13. So when I square that, there'll be 25 over 169. So if we subtract 1 minus 25/69 is 144 over 169. And then let's square root. Remember, when you square root, it's plus and minus. Now, in quadrant 3, sine's negative, cosine's negative, tangent's positive, because it's all students take classes. Tangent's positive there. So the cosine there should be negative. So it'll be negative 12 over 13. Well, now we could find tangent, maybe. Tangent is sine over cosine. So sine is negative 5 over 13. Cosine is negative 12 over 13. The negatives cancel, and then we divide by multiplying by the reciprocal, and the 13s cancel out, leaving 5 over 12. And the rest of them are really easy. Cosecant is the reciprocal of sine, so the reciprocal of sine would be negative 13 over 5. Secant is the reciprocal of cosine, so it would be negative 13 over 12. And cotangent is the reciprocal of tangent, which become positive 12 over 5. Why don't you pause this and try number 3? As a reminder, since it's between pi over 2 and pi, you're in quadrant 2, and it's all students take classes, so sine is positive, cosine's negative, tangent's negative. Alright, so answers. Secant is negative square root of 58 over 7. Cosine is negative 7 square root of 58 over 58. Sine is 3 square root of 58 over 58. Cosecant is square root of 58 over 3. And cotangent is negative 7 over 3. We can also use trigonometric identities to simplify expressions. Like this one. It's multiplying, so let's multiply. 1 times 1. 1 times negative cosine. Cosine times 1. And cosine times negative cosine would be negative cosine squared. Those cancel out, so I have 1 minus cosine squared. Well, we have this identity that says sine squared u plus cosine squared u equals 1. So if I subtract cosine squared, I'll have sine squared equals 1 minus cosine squared. So 1 minus cosine squared is sine squared. Why don't you pause this and try number 9? cotangent is cosine over sine. The sines cancel and you're left with cosine. Some of what you'll be asked to do is to verify trigonometric identities. It's kind of like a proof. You show that a trig identities are true by turning one side into the other side. So you work with one side at a time, usually the more complicated side. And you try things like factoring, adding fractions, squaring, whatever. Use your identities. If none of that works, try rewriting the whole thing in sines and cosines. But you must try something. Just sitting and staring won't help. You have to try something. Let's try verifying this identity. If I start on the left side, maybe I could rewrite this as sines and cosines. Secant 1 over cosine. Tangent is sine over cosine. So that gets me 1 over 1 minus sine over cosine. Well, divide a fraction by multiplying by the reciprocals. It'll be 1 times cosine for 1 minus sine. And then I really need to get rid of a denominator. So I'm going to use the fact that cosine and sine are related with the Pythagorean identity. So I'm going to multiply the top and bottom by 1 plus sine. And that'll get me sine squared, because I'm going to use sine squared plus cosine squared equals 1. Or if I subtract the sine squared, cosine squared is 1 minus sine squared. So on the top, I have cosine times 1 plus sine over, it'll become 1 minus sine squared. 1 minus sine squared, though, from up here is cosine squared. Now one of the cosines cancels out, and I have 1 plus sine over cosine. Now that I just have one thing in the denominator, I can split it up into two fractions. Be 1 over cosine and sine over cosine. Well, 1 over cosine is secant, and sine over cosine is tangent. And there we are. That's what we were trying to prove. Now that was a hard one. Why don't you try one that's a little bit simpler? Why don't you try number 21? Should recognize that this is sine of x, and cotangent is cosine over sine. The sines cancel, and you're left with cosine.